Welcome to the deep dive. So we've got sources on gender differences, but today we're not just looking at the findings, we're going deeper.
We're looking at the blueprint, the methodology.
Exactly. How is this information gathered in the first place? And here's a fact that just jumps right off the page.
I think I know the one you're talking about.
The FDA. Until very recently, there were no mandatory requirements for designing clinical trials to specifically look for sex differences in how people react to drugs.
Yeah, it's pretty shocking. I mean, most trials, even animal studies, were just overwhelmingly male.
Which has real health consequences.
It does. And the NIH finally stepped in, what was it, 2015?
Yeah, 2015.
They made government funding contingent on, actually factoring sex into the research design, unless there's a really strong reason not to.
Which signals just how big of a blind spot it was.
A huge one. But it's not just about who you include in a study. It's also about how you interpret the results.
Right. The sources get into this. The two big traps.
The maximalist and the minimalist approaches. A maximalist, they'll find a tiny difference and blow it way out of proportion.
Men and women are from different planets because of one small cognitive test.
Exactly. And the minimalist does the opposite, dismissing a real statistically significant finding as just, noise.
So the key question is always, how big is the difference, really? How much does it matter?
Precisely. Statistical significance just tells you it probably wasn't a fluke. For the actual importance, you need to look at what's called effect size.
And that's where the D statistic comes in.
That's the one. It basically quantifies the difference in standard units. So let's take an example everyone can see. Height.
Okay.
The height difference between men and women has a D value of 2.0. That's a very large effect. You notice it in everyday life.
Sure, you do.
Now, compare that to something like perceptual speed, where females have a medium advantage. It's a D of negative 0.48.
So it's there, but it's not nearly as dramatic.
Not at all.
Yeah.
And then you get to something like self-esteem in people over 60. The D value is 0.03.
0.03.
It's negligible. I mean, it's basically nothing in the real world. The D statistic just forces you to be honest about the impact.
Which is vital. But this all depends on how the data was gathered to begin with. The sources mention 4 main research designs.
Right, but the one that's most relevant here is the ex post facto design.
Because you're comparing groups that already exist. You can't randomly assign someone to be a man or a woman.
And that's where you hit the wall. It leads you right into the biggest trap in this kind of research.
Correlation is not causation.
The classic mantra. So a study might find that, say, college men's hostility toward women correlates with their friends' hostility.
Okay.
But you can't say one caused the other. There could be a third variable, like maybe adherence to rigid gender roles. That's